Welcome back to C++ with Miyoshi. Today I'm just going to show you an example of a class that we're creating, and then you create, I show you three different files. One that shows the .h file, the header file. One is this .cpp file, which is the other part of the class, and then class definition, and then a regular source file that's got the implementation or the instantiation of that object. So, back in the old days, and for those of you who don't want to use pragma once, then we had these pound if not defined, and then you gave the class a specific name. Usually their all caps was a kind of a Microsoft thing, but then there's no dots in there, so you want to put the underscore for the dot, if you will. So this is my circle.h file, so I have circle underscore h for my not defined. So this makes sure that it's only done once. So if it's not defined, then it's going to define it. So pound define the circle underscore h, and then at the bottom of my code I'd have pound endif. Now you don't have to do that anymore. If you want, you can use this pound pragma1, which is what I've done. I started doing that last couple years. So anyway, this is my circle.h file, and all this got in is the definition. These are my prototypes for my methods, and it's got my data in it. So I might have some other includes in here, but basically these are the two that I'm going to use. I use the math pound define underscore use math underscore defines for my so I can use pi in there. I can use capital M underscore capital P capital I for pi. And then I got the pound include math, and I need that for the math includes as well, or math defines. And then I've got this keyword class, and if you recall, at least in Visual Studio, it shows up as blue, my keyword, and then here's my variable name, if you will, my class name. So I have a keyword class, and that's very similar to structure, and if you recall structures, it looks very similar to a structure, but in a structure you'd only have your data here, you wouldn't have the methods. In C++, in fact, though, you can have methods associated with a structure. So anyway, I have a class circle, and I've got my open close curly brace at the end. I have a semicolon there. I've got my private colon. Private colon says that this data can't be, or this method, if it was a method, but this data can't be touched outside of my objects created by this class. If I have a protected, then you can use that for, so if you want to access data in derived classes, you can do that, but I stick with private for the most part. I've got public colon, and this is the things that my program or other objects outside of this class can access. So I have my circle, this is what's called a constructor. This is my default constructor with nothing inside there. That just says, hey, this is what's going to happen if you don't give any parameters to it. My circle with my one input parameter that says create a circle with whatever that input parameter is. This is what's called the copy constructor, and what it's going to do is if I give it another circle, it's going to have the same parameters or the same data, the same value for the data in that guy. This tilde with a circle, that's called my destructor. Usually there's not much in there, so a lot of people will not even put that there. But as you get in more complex code, you're going to have a destructor and figure out how to get rid of your different objects or parts of your object. I have a set radius. This is one of my setters. I have a void. It's a set radius, and it's just going to give me a radius for my circle. I have a float get radius, which is going to return back what the radius is, because once I set the radius, I can't go in and see what the radius is unless I have this getter, if you will. And those two, again, are called accessors. I have the stuff that does any real things. That's my float circumference and my float area. Those are just going to return my area. Notice at the bottom after my semicolon, I have a pound include circle.cpp. And what this does is just like any includes, what it actually does is take whatever files here, and if it's in the double quotes, that means it's in the folder where you're taking your solution. If it's in the triangular braces, like up here, that says go to what the compiler defaults are, or whatever you set for those guys. But this says take all that code that's in circle.cpp and stick it right here as if they were one file. And in fact, you could make this all one file, but lots of people like to include or have a .h file and a .cpp file, especially as we get bigger and more complex classes. So that takes us to our next file. In this my circle.cpp file, what I have here is all the definitions of all these methods and constructors. So I have my default constructor, and in default constructor, it's nice to make sure that you get your data, set them all to zeros or set them all to something that makes sense, setting them up. I have a circle, my circle with a parameter inside there, so I'm going to give it a float input, and then my radius is going to be assigned the input value. Notice that this r refers to this private variable over here, r, and they are the same. Everything here is only related to the class. Everything here is only related to the class. And the way you know that is with the circle : : that says if that's not in front of there, if I just had a circle, it wouldn't know what to do with it, because it says, hey, what's a circle? And you have to have the circle : : to say that this is the circle associated with that circle class. Okay? Circle : : circle with a circle ampersand C. This is called my copy constructor. So what happens is, if I want to create a circle from another circle, I can use this r to assign the value c.r. That looks like it violates the data hiding principles of object-oriented programming, but it doesn't, because its circle is made from another circle. I can access its data, even if since it's private, only other circles can access it, but it can access it with just the dot notation. Okay? My destructor, my circle : : tilde circle, open close parentheses. There's nothing in that guy, so I just have it open and close curly brace right there. And then I have my set radius, my accessor for setting the radius, my accessor for getting the radius, my setters and getters, if you will. Set the radius to be the input, or just return the radius when I do the get. Then last but not least, my last two, the two that really do something for me, are my circle : : circumference. Notice it's got my return type. These guys have return types because they are methods, so which are just functions. They have return types in front of the circle : : circumference, or the circle : : area. The circumference just returns the circumference, the perimeter, if you will, of a circle. And that's just pi times the diameter, or pi times 2 times radius. Notice I like to put the 2.0 to distinguish that it is a floating point operation, and you can do that if you'd like. And then I have under here, last but not least, my area. I have an m_pi times radius, or r squared. There is not an r squared per se with C++. You'd have to use the pow function, but I like to use r times r because it's a lot quicker than just pow in this case. Okay? Once we get our class defined, so here's my whole class, it'd be from there to there. Now remember, this count include just says, take all this stuff that's in my circle.cpp file and stick it right there. So once this guy is all ready, you can then write a testing program to make sure it works. And that's what this last thing is. I have a source.cpp, and you can call it whatever you want, circle tester, or test program, or test.cpp, whatever you want to have that. We're going to call that whatever we will. And I'll have whatever includes I need for input and output and all those kind of good things. And then I need to make sure I include my circle.h. Again, the double quotes say grab it from the projects directory rather than from the compiler's directory that you want to do there. So I have my int main, my open and close curly brace at the front and the end. Oops, I did forget to put in my return 0 at the bottom. But we have my instance of my circle is created, so I'm going to instantiate my circle. Again, that just means I'm going to declare my circle and then use it. So this says to the compiler, hey, save space for my circle, and we're going to use that later on, and it's got all these things associated with it. So it's got my circle, and I have an error. I like to do this to show people that, hey, if you try this at home, or my students, if they try it in my class, if I do c.r as assigned the value 3, trying to set my radius to be 3, that doesn't work. That's actually going to give me an error because, hey, it says the r is private, or it'll give you some error that says you can't do that. So what you have to do is you have to use the accessor in this case, my set R, my setter. So I'll do C dot set R, and then I'll put my 3.0 in there for my radius inside my parentheses, and that will set the radius to be 3. Now, notice the dot notation here comes from the C dot, then in the accessor. And this notation here, again, even though it's a dot notation, that doesn't work because the data is private. Okay? And then last, all I'm really doing here is doing a printf. All I'm doing is outputting my circumference in my area. One other thing about C++ and other programming languages like C++, notice that if I don't have the comma and then I have this on a new line, it doesn't really care about that. White space doesn't really matter. That's the nice thing about many programming languages is you have that white space doesn't really make that much difference in this case, except for maybe for readability. So I have printf, I have my circumference, just a label C for circumference, my %f for my float, a tab between them, my area, label for the area, my %f for my placeholder for my area, and then a new line for my output. And then I'm just going to do this, the dot notation again, C dot circumference, open close parentheses, that calls the method or the function for the circumference. And it's just going to get down here, oops, where'd it go? It's just going to do my m underscore pi 2 times radius, and then output that over here. Let's find the area, do the same thing, m underscore pi times r, output that here. And then last but not least, that finishes the kind of the program. Here I have just a couple more things. I just said, oh, well, if I have my copy constructor and my other constructor, I may as well use them. And so I've got the circle C1. I've created a new circle, give it a value of 5, or 6 if you can't read that well, but it looks like a 5. And then I've got a circle C2, and that's a copy constructor of C. So this circle C2 is going to be identical to this first C, so it's going to have a radius of 3. So if I called these same methods, but with the C1 dot circumference or a C2 dot area, I'd get the respective proper calculations done. Okay? So, one of the best ways to learn C++ or any programming language is to take some code that you have seen or that you know and then modify it and use it appropriately. So that's one of the things that I do. I have given you the code for the circle class, and hopefully you'll be able to use that well and then get more familiar with classes and object-oriented programming. So thanks for tuning in for C++ Miyoshi. We'll see you next time.